everyone, welcome to my channel. In today's video, I'll be covering one more Scilab Practical on probability theories, conditional probability. So before I take this question, let us understand what is conditional probability. So here I have taken definition of conditional probability from the Google, but I'll explain you what it means. Conditional probability. Conditional probability refers to chances that some outcome occurs given that another event has already occurred. That means when you're finding probability of any event, that time you take into consideration that the event A has already occurred or the first event has already taken place, and depending on that you're going to find out the probability of your next event. This is how we denoted P of B slash A. Here slash means given that. This we are going to read as a given that. So it means probability of the event B given that event A has already occurred, has already taken place. So here in the next line you will find that it is often stated as the probability of B given A, and it is written as P of B slash A, where the probability of B depends on that of A happening. Alright, so let us understand this with an example. I'll be giving you a formula now which will help us in finding the probability of any event taking into consideration that the event has already occurred. Suppose there is a box in which there are 4 black balls and there are 6 white balls. So in all we have 10 total balls with us. Alright. Now you have to draw 2 balls. Draw 2 balls at random. And we are asked to find out what is the probability that both the balls are going to be a black ball. The first ball which you will be removing, that should be black, and as well as the second ball which you will be removing, that should also be a black. So and what is that? That means you have to find out the intersection. So I have to find out B1 intersection B2. Alright. So how am I going to do it? So let us understand the working of it. Alright. So here I am going to define 2 events. Alright. All of us know what is event. B1 with the event that the first ball drawn is a black. First ball drawn is a black. Whereas B2 I am going to define as the second ball drawn as a black. Alright. So basically what I have to find out, both the balls should be black balls. So I have to find out probability of B1 intersection with B2. Alright. So how am I going to find out? So let us understand this. Alright. So I have to find out probability of B1 intersection with B2. So first, all of us know that first we are going to find out the probability of drawing a first ball as a black ball. First we are going to find out the probability of drawing first ball as a black ball. Into, since intersection is there, so operation will be multiplication. Into, then we are going to find the probability of the second ball as a black ball. But that time you will keep in your mind that you have already removed the first black ball. You have already removed the first ball which was black. So here you can see, here we are finding the probability of the next event, keeping in our mind the first event has already taken place. Alright. So when you will find probability of drawing first ball is a black ball. So right now in the initial stage, how many black balls are there with us? There are total 4 black balls with us out of 10. Alright. So probability of me removing one first black ball is going to be 4 upon 10. Now I have removed 1 black ball. So how many balls are left? 3 black balls are left. White balls will be as it is. So total ball will be 9 balls. Alright. So when you will remove second ball as a black ball, so you have total 3 black balls with you upon total balls are 9. So here you can see when you're finding the probability of the next event, that time you're keeping or you're taking into consideration that the event A has already taken place. So this is how the conditional probability are being used over here. So this was the definition of conditional probability, right? So when probability of finding any event, keeping in our mind or taking into consideration that the first event has already occurred. This is what it means. Now you have the answer 12 by 90. All right. So this is the answer of this question. So from here, what we got to know? So whenever we have to find out probability of A intersection B, so first we are going to find out the probability of first event into when you will find the probability of the next event, that time you have to take into consideration that event A has already occurred. But we want formula for probability of conditional probability, that is this. The formula is going to be probability of A intersection B upon probability of A. So this is the formula, students. So whenever we have to find the probability of any event, given that the first event has already occurred, the formula is probability of intersection of both the events upon probability of that event which has already taken place. Now what is the formula of this finding probability of any event? It is number of element in an event upon total number of element in a sample space. Similarly, probability of A will be number of element in an event upon total number of element in a sample space. So this and this will get cancelled. What will be left with you? So probability of B slash A is going to be number of element in an intersection upon number of element in an event. So this formula you'll have to remember for conditional probability, that whenever you're finding probability of any event B, given that some event has already taken place, so the answer is going to be number of elements in an event of intersection upon number of elements in an event that has already taken place. Alright, this is very important. So this is the formula for conditional probability. Now let us understand the question. So we are given a pair of dice is tossed. We all know that whenever a pair of dice is tossed, there are total 36 possibilities. Write a Scilab code to find the probability that one of the dice is 2 if the sum is 6. Now here we are going to apply the concept of conditional probability. Why is that so? Because we are asked to find out the probability of the event that one of the dice is 2. Given that if whatever statement comes after if word, that is given to us. So if the sum is 6, so sum should be 6 and one of the dice should be 2. So what is the probability of that? So how are we going to solve it? So whatever is the statement after if, that is given to us. So for that I'm going to define one event A. Let A be the event that the sum is 6. And whatever I have to find out, I have to find out the probability that one of the dice is 2. So that I'm going to take it as B. One of the dice is 2. So what I have to find out? I have to find out probability of which event? A or B? B. Find the probability of the one of the dice is 2. So I have to find the probability of B. But you have to keep in your mind that the event A should be there. Event A has already occurred, that the sum is 6. So this is what I have to find out. All of us know what is the formula. It is going to be number of elements in an intersection of A and B upon number of elements in an event which is already taking place, that is event A has already taken place. Alright. So let us see how the answer is going to be. So whenever we roll a pair of dice, that total 36 possibilities, and all the 36 possibilities I have written over here. 1, 1, 1, 2, 1, 3, 1, 4, and so on till 6. Since I have defined my event E as sum is 6. So in which all cases you will get sum as 6. So 1, 5, the sum is 6. 2, 4, sum is 6. 3, 3, sum is 6. Then 4, 2, 5, 1. So 1, 2, 3, 4, 5. In 5 cases, you will get sum as 6 when you roll a pair of dice. Alright. So So this is going to be your E, in which you're storing the sum is 6. So 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. And the next event was, let us take it as B. The next event was one of the dice should be 2. So in which all cases you get sum as 2. One of the dice is 2. 1, 2. One of the dice is 2. Either first on first rule you should get 2, or on the second rule. But at least 1, 2 you should get when you roll a pair of dice. At least 1. It can be more than 1 also. So 1, 2, we are getting 2 at least one of the places. Then in case of 2, 1, 2, 2 will also be considered because we are getting at least 2 in one of the pair. Then 2, 3 will also come, 2, 4, 2, 5, then 2, 6. Then 3, 2, 4, 2, 5, 2, and 6, 2. So in all these cases, we are getting 2 on one of the places. So all these options, all these possibilities, we are going to write in. So 1, 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then 3, 2, 4, 2, 5, 2, and 6. So all these possibilities will come under an event B, in which we have put all those possibilities in which one of the dice is 2. And in the first event we have put the sum is 6. Alright, what I have to find out? I have to find out the probability of B given that event E has already occurred. Formula is probability of B intersection E upon, number of elements in an intersection upon number of events which is already taken place, that is E. So how many elements are going to come into intersection? So you can clearly see from the diagram also in which all cases we are getting the intersection. Here you can say 2, 4 and 4, only these two are common. 2, 4. There you can say 2, 4 and 4, 2. Okay. So 2 upon, how many elements were there in this? 4, 5. So 2 upon 5. So how much is 2 upon 5? That is going to be 0. So 0.5 is the answer for this question. Now let us see how we are going to write down the code. I hope you will have understood the theoretical part of it, how are we going to solve it, because when you know the concept behind the question, it is easy for us to write down the code. Alright. Now we see the code and accordingly we'll try to execute it on Scilab Practical. So what is this first line is going to do? All of us know that first line is going to print the statement as it is. What it is going to print? The experiment that a dice is tossed, that a pair of dice is tossed and the outcomes are observed. Next line will display to find probability of an event that one of the dice is 2 if the sum is 6. Now here we have taken event E. What is this E stands for? That I have written in the green color, you can see over here, which stands for comment line. Which means event that the sum of the two numbers on the two dice is 6. So all of us know that in these 5 cases we are going to get sum as 6. Next I have defined event A. What it means? It stands for the 2 appears on at least one of the dice. At least one of the dice. So in 2, 1, 2, 2, 2, 3, all this will come, and then 1, 2, 3, 2, 4. In which in all these cases we are getting 2 on at least one of the dice. Then we are going to find out the intersection. As you all know, what was the formula? The formula was number of elements in an intersection upon number of elements in an event which has already taken place. So intersect keyword is already there in the Scilab. So we are just going to give command intersect of whom? E and E. So that I have written A, E. That I have stored in a variable B, and I am interested in knowing the cardinality of this. Cardinality is what? How many elements are there in the set B. Alright, because we are interested in the number of elements. If you look at the formula, which is, I'll just highlight over here, you can see the formula over here. So I am interested in number of elements in that event. So in the next line, I am writing the formula length of B, because the formula is number of elements in an intersection. Intersection is stored in a variable B. So length of B. So length command is used to know how many elements are there in the set B. So that is why I've written length of B upon the event which is already taken place. The event E has already taken place, so length of E. And then they have stored in a variable PM, and that in the next line I'm going to display the variable along with the statement that to find the probability of an event that one of the dice is 2, the sum is 6. Alright, so this was the code which was very easy. So here I have defined 2 events, one which was already occurred, one which we have to find out. Then what was the formula of the conditional probability? The intersection of those elements upon the event which is already taken place. So very simple, keep things very simple in your mind that it is number of elements in an intersection upon the number of elements in an event which is already taken place. But the problem over here is if I write the same code as it is in the Scilab, it is not going to give you the output. Why is that so? Because of the line E and A. You just see the variable E and A. In that we have stored values like in an ordered pair, which is not accepted by the Scilab. So here I have modified the code. Okay, but everything will remain same. Instead of writing 1, 5, I will write 1, 5. So in 1, 5, it is understood that first dice is 1, and on the second dice we are getting 5. You see, as you can see over here. So instead of writing 1, 5 in an open bracket, I have written 1, 5. So that Scilab can understand what all values are stored in a variable E and A, and accordingly it will count and it will give us the output. This is only the correction which I have made over here to get the output, and rest all will be as it is. And also I'm displaying what all values are stored in a variable E. You can see over here, display the sum of the dice is 6 E, and then I'm storing in a variable E that I'm displaying. Alright, now let us execute it and see the output. And the output we will get it on a console window. You can see over here, this is the output. So all of us, we had written 2 display line at the top that has been displayed over here. Then I'm displaying the one of the event that some of the 2 numbers are on the dice is 6. So in this case you will get 6, and then 2 appears on any one of the dice. So these are the possibilities, and then I'm displaying the intersection, and the final answer is 6. I hope you will have understood this code and made the corrections accordingly so that you can get the output on your Scilab console window when you execute. Okay, thank you for watching.